Hey everyone, in this video we're going to be looking at the basics of finding the area of some triangles and some quadrilaterals. What we're really doing in this video is just going through all the different formulas that you're going to need to know for all these basic shapes. To start us off, so area is the space within a 2D shape measured in units squared. And so there are formulas for finding the area of a shape. Really quickly to illustrate what we mean by the concept of area. If I had a little square, say that was 1 millimeter by 1 millimeter, that is the definition of 1 millimeter squared. And then similarly, if I then had like 1 centimeter, this would be 1 centimeter squared. So it's like a squared version of a centimeter. This is what we mean by two-dimensional measurement. Here I've got one dimension, the 1 centimeter going that way, and then I have another dimension going the other way. So the little 2 sitting in the unit tells us that that is the area within this 2D shape. So it's a two-dimensional measurement. So going right into these formulas. The first formula we're looking at is the triangle, and with our triangle, all you need to know is the length of one of the sides. So we see that we're just going to call that the base, and then also the height. And one thing to note about these two measurements that are going to be between, there needs to be a right angle between those two lengths. So we have the base and we have the height. It doesn't necessarily need to be one of the lengths of that triangle. They just need to be cutting each other at 90 degrees. And the formula for that, as we see down here, is half times the base times the height. So you simply multiply your two lengths and you half that at the end. So looking at this example that we have here, we see that the length of this side is 7 centimeters, and then we also are told, we're not told the length of that side, but we don't really need it. Instead, we're told that this height is 4 centimeters, and if we were to kind of extend this across that line, we'd see that they are at a 90-degree angle, and that's all that really matters. The two lengths need to be at 90 degrees. So now that we've got that, our area is going to be half times 7 times 4. It doesn't necessarily matter which one is the 7 and which one is 4, which one's the base, which one's the height. We've got 0.5 times 7 times 4, and this equals 14. And we see that the units are in centimeters, so we've got 14 centimeters, and making sure that we're writing the correct unit, so it's 14 centimeters squared. And that's all there is to it. Next one, probably the easiest shape there is the square. And as we know, a square is where we have all four sides are equal and all the four angles are 90 degrees. And so we just do the length squared. So if that's the length, that means that's also the length. And the way we find that is we would do length times length, which is length squared. So in this example here, although it might look like a diamond or whatever shape you might want to call it, at the end of the day, all the four sides are equal and all the four angles are 90 degrees. So it's just a square that's been rotated a little bit. So here we say that the area is 2 squared, and 2 squared is just the same as 2 times 2, which is 4 meters squared. Again, noting that this measurement was meters, and so our unit is meters squared. Going to the next one, we have the rectangle. Again, probably if the square wasn't the easiest one, then the rectangle certainly is. And it's just we're going to have one side length, which is we're going to call the length, and then the other one, which is the height. Doesn't matter which one's which, we just multiply them together. So looking at this example, I forgot to add some numbers. So let's say we said that this was 3 centimeters, and maybe we said that this was 8 centimeters. And then so the area of this, very, very simply, 3 times 8 equals 24 centimeters squared. Very easy. The next one being the parallelogram. This is where we start to see a bit more less basic shapes, but still all comes down to a formula. So the first thing we see here is a parallelogram, with these parallelograms, we see that we're going to be told one of the lengths, okay? And then we're also going to be told the height of the shape. And just like what we saw with the triangles, they need to be at a 90-degree angle. If they're not at 90-degree angles, then we can't use it. So we're not being told the length, that slanted length, because that's not actually going to, they're not meeting at 90 degrees. So we can't use that length. So we'll be told the length, we'll be told the height. And the way that you can kind of remember what a parallelogram is, a parallelogram is just a rectangle that's been pushed over. So it's a pushed over rectangle. And so if we know what the rectangle was, the area for a rectangle we just saw was length times height. So this is also just going to be length times height. So in this question here, the area is going to just be 9 times 5, which equals 45 centimeters squared. That's all there is to it. Second last one, and we have a combination, rhombus and kite. The reason why we're going to have rhombus and kite on the same page is because they both have the same kind of measurements and they both have the same formula. So a rhombus we see is kind of like a square that's been pushed over. We see that all sides are equal to each other. However, unlike a square, this isn't a 90-degree angle. Okay, so that makes it a rhombus. So it's a square that's been pushed over. And with our rhombus, we're going to be told the two diagonals. The long diagonal we'll call X. The short diagonal we'll call Y. It doesn't really matter which one is which, but we're just going to label them X and Y. And same with a kite. The difference between a kite and a rhombus is we see that these two sides are equal to each other, and these two sides are equal to each other, but they're not all equal to each other. So it's kind of like a rectangle, except the opposite sides aren't equal. The sides that are next to each other are equal. Again, though, we're told what the two diagonals are, so we call the short one Y and the long one X. We could call the long one Y and the short one X. Again, it doesn't matter. And the formula for each of those is half times X times Y. So it's basically saying multiply the two diagonals and halve it. So looking at this example here, we have this being a kite. This is a kite because we see those two sides are equal. These two sides are equal. So this makes it a kite. And so we also know what the diagonals are. We see that this going across would be 7 and this going across would be 12. So our area formula that as we just wrote down is area equals half times 7 times 12. It doesn't matter if I do half times 12 times 7 either. And then once we put that into our calculator, we'll get 42 centimeters squared. So that's just half times the X times the Y. And then our last shape for this video is the trapezium. Trapezium is probably the most complicated one in this video, but it's still not too bad. What a trapezium is, we see is we have two sides that are parallel to each other. So this side here and this side here are parallel, meaning if they were to go forever, they would never touch. We're going to call those two parallel sides A and B. Doesn't matter which one's A, which one's B. And then we're also going to have the height of that shape. Basically, just like what we've seen with all the other ones, we're talking about the perpendicular height. It needs to be hitting at 90 degrees. So with those three numbers, the way that we find this is we do half times the height times the sum of those two parallel sides. Note in particular that there are brackets. If you don't use those brackets in your calculator, you will get the answer wrong, because the brackets forces you to do order of operations. It's going to do the A plus B first, and then it's going to do half times the height times that. So looking at this example, we kind of have a trapezium that's tilted on its side, but we can still look at everything like it's still a trapezium. So we've got our two parallel sides. So I can call that one A and I call that one B. Doesn't matter which one is B and A. And then this is the perpendicular height between those two sides. So this would be my H. So then just putting this into the formula, we have area equals half times 2 times 2.5 plus 5. Making sure we're using those brackets, because then once we put that in, we go half times 2 times in brackets 2.5 plus 5, and make sure you're doing the plus inside the brackets, not times. And then this would be 7.5 meters squared. So that's it. Those are all the formulas you're going to need to know for the basic triangles and quadrilaterals. Just to recap, we have triangles, squares, rectangles, parallelograms, rhombuses and kites, and trapeziums. Thanks for watching.